Hi there. We're going to do a little project. So this is very similar to what you would see in a typical electrical circuit in any piece of heavy equipment. It could be an on-road truck, it could be a dozer, an excavator, even your car or truck. That's something similar to this. What we've sent you is a little kit in a bag, just like this, full of parts, full of goodies. So you should have one of these in front of you. And inside is a whole bunch of components. What we're trying to do here is simulate a lighting circuit. So any circuit that you'd see on a vehicle is made up of these similar components. So we're going to start with the base of any electrical system. Every vehicle has a battery, so you'd normally see the battery under the hood of your car or truck, or on the side steps of a tractor, or someplace on a piece of heavy equipment. So this little battery is going to simulate a car battery. Much smaller, but it's going to do the job for us. Then we have a connector that connects the battery to the rest of our circuit. Every electrical circuit has a circuit protection. So in this case, we're going to use an inline fuse. And inside of this little guy, see a couple of terminals, and that's where this little fuse is going to go. So we're going to leave that ready to go there. We're going to hook these up in just a second. From the fuse, we're going to connect to a switch. So here's our little switch. What you'll notice in some of these kits is the switch might look like this with the blue leads, or some of them might actually have a larger, heavier switch that's in a package that looks like this. Okay. Then from the switch, we're going to go to this little bulb socket. Okay, so this is the socket that our light bulb is going to fit into. This is the fragile piece, the light bulb. These fit together. Okay, so to start connecting the circuit, and what we'll need to do is look at all of our wires, and you'll see that on the wires, some of them are stripped, so there's a little piece of insulation missing off of it. That's required to be able to connect the wires together. So what we want to do is we want to strip the wires. These are stripped a little bit, but we want to get a little bit more of that insulation on. So you're going to take your wire strippers, and what you'll see on the side, someplace on it, you'll see the small letters. And those letters tell us what the wire gauge is. So the wire gauge, you'll notice that the notches get bigger as we go up this ladder here. And as we get bigger, the number gets lower. So the bigger the number, the smaller the wire, or the smaller the number, the bigger the wire. So it works kind of backwards than what you'd expect. The small wire is somewhere in a 24 or 20 gauge, and that's how we describe wire size. It's based on gauge. So you can tell this is a fairly small wire. This I'm going to tell you is about a 24 gauge wire. So we're going to go right down to the bottom. And what you're going to try and do, if I turn it a little bit sideways, you'll see that I've now lined up the stripping notch a little ways back on the wire insulation itself. And you're just going to give it a little squeeze, and then you're going to pull. Okay? And now you see that the insulation is stuck to the pliers, and I stripped off a little bit more insulation off the end of it. So now that we've stripped both wires on the battery connector, we're going to move on to the fuse holder. You'll notice the distance, or the amount of wire insulation that we stripped, is about 1/4 of an inch. And what we need to do is the same thing on this wire. Just as a 12 gauge wire, so have a look at your pliers and see if you can find yourself a 12 gauge notch. A 14 gauge will work as well, but just make sure you have a little bit less pressure when you squeeze it. You don't want to cut any of the conductors inside the wire. So again, you want to come back to about 1/4 inch, 1/4 to 3/8 of an inch, squeeze it, and pull. And that wire insulation should slide right off. So next up, now that we've stripped the wires on the fuse holder, we're going to move on to our switch. And we're going to have a look at this one. You'll notice that the wires are quite long. We don't need that much wire on this, so we're going to use the wire strippers again. You'll notice that on most wire strippers, not only can you strip wire, you can crimp with them as well, but there's also wire cutters. So down here in the bottom, and you have to look at your wire strippers to see exactly where it is, there's a cutting blade down in the bottom, the throat of the tool. So I'm going to go ahead and leave just enough to work with, maybe about 6 inches, and you can cut 1 or 2 wires at a time. I'm just going to give those a snip, and I'm going to repeat the stripping process that I did on the other wires. We're going to use our handy tool again. What you'll notice again on that tool is that it's not only a stripper, and we've talked about how it cuts wire, but also it's got a crimper. And again, your tool might vary, it might look a little bit different, but we're going to use these little connectors. These are called butt connectors. And the reason they're called butt connectors is because we butt the wires together. So inside the connector is a little sleeve that looks like this. So these two are actually from the same. All I did is I stripped the insulation off the outside, and the insulation is just there so it doesn't short out. It keeps the wire protected inside. So the way the circuit works, we're going to start at the battery, just like this. Red is always positive. So just like in your car or truck, that's going to be the positive side of the battery. We need to go to a fuse, so we're going to connect those. Then we're going to move on to the other parts of the system. What I like to do when I put these together is I like to give these just a little bit of a twist, and that just holds all the conductors together. So if you look at the other side, it's kind of furry and falling apart, not real tight together, whereas this side is nice and tight. We're going to start with the big one, we're going to slide it on, and again, just a little bit of a twist in the same direction, and try and get it in there far enough where it's not, everything's protected. You shouldn't be able to see any bare wire on the outside of that connector. Take your crimper, and again, try and line up that. I'm just looking down inside, and I'm going to turn my pliers so that split in the connector is in the right place, and go ahead and give that a squeeze. You might need to use 2 hands, and that should be on there nice and tight. Now we're going to go ahead, give that a tug. It's not going to fall off of there. Everything's good. Now I'm going to take the other wire, I'm going to put it inside, hold it down in place if we can. Sometimes what works for this is if you take that set of pliers and just hold it. Hold the connector with the pliers itself, then you have a free set of hands. And you can get a little bit better control. So now you're going to squeeze that down. The little wires you really want to squeeze hard, nice and tight. Make sure that's not going to pull apart. Give it a gentle tug, it should stay in there. So now from the fuse, we're going to keep on connecting the circuit. We're going to go to a switch. Switch doesn't matter which way you put it in. It's just an on-off switch. Nice little tug. And then now we're going to go on to the light bulb. Another little tip here. When you actually look down inside these butt connectors, we'll see if we can get a shot right down inside it. And if you look right down inside it, you'll actually see that there's a little tab kind of poking up in the middle. And what the little tab's for is it stops the wire from going too far. Okay, so you can shove the wire in there, it's going to run up against that little tab, and it's right in the dead center of it. It's going to stop the wire from going too far. So that's always a good thing to know about too. We're almost there. So you'll notice that this whole circuit is just about being completed, right? So we go from a battery through to a fuse, through to a switch, to a light bulb, and now the light bulb needs to get back to the battery. So now to connect the wire, we're going to use the side of this socket. So what you'll find here, you can do this a couple different ways depending on how your socket is put together. Because we don't have a second wire to hook to, we're going to use where it's been stamped to hold that bulb. So I'm just going to put the wire into that hole, just like so. And then I'm going to insert the bulb. And the way these work, they've got a couple of little bumps on the outside of it. You can see on the edge, 1 and 2. And those index down into this connector where you can see the bumps on either side. And to connect these, you need to line up those bumps with the grooves in the socket. It's spring loaded, so you got to push it down, give it a little twist, and it actually connects. It locks into place. You can see kind of the J-shaped groove there. So again, you can push it in and you give it a little twist and it holds it in place. Okay. So I'm going to take the bulb, push it in there and into place. And what it's done is it's actually connecting the conductor to the body of the socket. We're almost there. We're almost to the point of seeing this light bulb light up. So we want to hook up the battery, then we're going to do the fuse. Line up the sockets accordingly so one fits inside the other. You can't really mess this up. And you're just going to push that in, 1 and 2. Now that's connected. And now the last thing we're going to do before we turn it on is put the fuse in. The way you look at fuses to see if they're any good or not. So by that I mean to see whether they're actually working. If you look inside through the window, you'll see this little Z-shaped piece right here. That's the element. So that's what actually limits the amount of current or electricity that can flow through it. If something happened and this circuit shorted out, more current would flow through that fuse than what was allowed, and it would actually burn that little element. And that's what would make that fuse inoperable, and the circuit would stop working. And you can see the two terminals inside. That receives the blades of the fuse, just like the fuse panel in your vehicle. Just gonna go ahead and put that in place, push it down all the way, and then we're gonna put the cover on. You look at the switch, it's got an on and an off. So now we're gonna test it. We'll see if we did a good job. Look at that. Now we have a full circuit. See if you can save a paper towel tube. You can put this on one end, put the battery on the other end, and voila, you have yourself a little flashlight. Congratulations, I hope it worked for you. This is a great, again, little step or look into what a career in the trade might be. Looking at a simple circuit, doing some diagnostics, figure out why it's working or not working. Now that you have a base understanding of how that works. Remember, anytime you're thinking about going into trades, apprenticeship is a fantastic thing. Get involved with skills, get involved with your local post-secondary, give the trade a shot. Good luck.